So hello everyone, we are back again with part 20 of the chapter Light, Reflection and Refraction. And in this video, we'll talk about formation of images by concave lens. So in the previous video, if you would have seen that we have discussed the rules for formation of images by concave lens, and now we will understand how to use those rules to draw the ray diagram. Going ahead with the situation, basically for the concave lens, we will have only two cases, which is case one when the object is at infinity and case two when the object is anywhere between optical center and infinity. So let's begin with case one when the object is at infinity. First thing we need to draw is basics, which is drawing a concave lens, optical center, focal length from O to F1 or focus from O at a suitable distance. And let's see, when we keep the object at infinity, the rays will come parallel and we get the ray diagram, which is diagram for divergence of light from concave lens. And you can see, as it is a diverging lens, light ray after refraction from concave lens will diverge and they will appear to be coming from a single point. So when we draw them backward, and we'll observe that at a single point, which is focus, they are meeting. So this is case one. And remember, as we have discussed previously also, that whenever you are drawing the ray diagram, it's very important that you are labeling the arrows. You're drawing the arrows properly, because without arrow, your diagram is incomplete. And you can see the arrows are drawn here also. So, and also writing the conclusion is a must. So going ahead with the conclusion, let's see what would be the conclusion. The conclusion would be, the image is formed at focus, which is highly diminished. The image will be highly diminished, and because it's on the same side of the object, so it is going to be real and it is going to be virtual and erect. So let's see the conclusion. When the object is at infinity, you can see the rays are diverging and we get the image at focus F1 on the same side of lens. The image is highly diminished, or we can also say it's a point size image, and because it's on the same side as the object, we say it's a virtual and erect image. So going ahead with case two, we draw the basics when the object is anywhere between infinity and optical center. So we can keep the object anywhere, and the moment we draw the object, you can see we'll use rule 1, which says a ray which is parallel passes through the focus for convex lens, but for concave lens it diverges and appears to be coming from focus. You can see, so rule 3 we'll draw is the ray passing through optical center goes as it is. So for rule 1, if we extend the rays backward, we will observe at this point the rays are crossing. Now you will observe this time it is one ray which is really crossing, the other one we have brought it, so which means the image which will be formed is not going to be real, because the rays out of the two ray, one ray is virtually crossing, so the image formed is virtual and erect. So let's see the conclusion. In this case, the image formed is between optical center and focus on the same side of the lens, diminished, virtual and erect. Let's see if I keep the object anywhere else, what happens. So if I keep the object, let's say at this point, the first ray will remain same. The second ray, if you'll observe, will pass this way. In any case, I will be getting the image between O and F only if I'll shift the position of object. So let's say, if some of you must be thinking, what if I keep the object between F and O? So let's see, if I'll keep the object between F and O, in that case also rule 1 will remain as it is, because the rays are parallel. And rule 3, if I'll try to draw, you can see I will get it here. And in that case also, the image will be obtained at somewhere here, you can see, and this is also between O and F only. So whatever be the situation, wherever you want to keep the object, keep it, but you will get the image between O and F1, and it is going to be diminished and erect, virtual and erect. So these were the cases for concave lens. And if you'll observe, there is some similarity between the results obtained in concave lens. So if I'll write it here, concave lens and convex mirror and convex lens and concave. So if you want to recollect and understand, these are the results. The result obtained by convex lens and concave mirror was similar. You would have seen we have drawn 6 ray diagrams for these two situations, these two objects, which is a convex lens and concave mirror, whereas for concave lens and convex mirror we have drawn just two ray diagrams. So if you have understood any one of the situation, which is mirror or lens, you will be able to draw all the other situations, and these will be helpful when we'll be actually solving the numerical. So this was all about the rules for formation along with the ray diagram for concave lens. In the next video, we'll talk about what are the uses of spherical lenses, and when we say spherical lenses, means concave as well as convex lenses. So that's it from my end. If you have any question, you can put it in the comment box. That's it. Thank you and have a great day. Bye bye.